and chords is what we're talking about today. Hopefully by the end of this lesson, you will understand a couple of different things about the arcs in a circle and also about their chords. Here's some major definitions that you're going to need to know about. Now, if you do not understand this terminology, then when it asks you to define a major arc, you're not going to know what they're talking about, okay? So, a central angle is an angle in a plane whose vertex is the center of the circle and whose sides are radii. So if you look down here at this picture, the central angle would be angle PAPB because the vertex is at the center, PA and PB are your radii, all right? Arcs is part of a circle, okay? So AB would be an example of an arc, okay? It's a section of the actual circle itself. A minor arc is an arc whose central angle is less than 180 degrees, okay? So, if it's a minor arc, it's less than 180. A major arc would be an arc whose central angle is greater than 180, but less than 360. Everybody knows that they're 360 degrees in a circle, yes? Good. A semicircle is clearly half the circle. So its central angle is exactly 180 degrees. The endpoints are the diameter. So the measure of the minor arc is the measure of the central angle, and the measure of a major arc is 360 minus the measure of its minor arc. So an example is already given to you right here. The measure of angle APB is 60 degrees. So that means that the arc AB would be 60 degrees, okay? The measure of the central angle is the measure of the arc it creates. Does everybody understand that? Yes. Because it's not related to the distance around. It's basically how much of that particular sector. So it corresponds to the angle as well. All right. So again, the measure of central angle is 60. That means the arc in between the angle is 60. Everybody gets that? Now, the measure of arc ACB would be 300 degrees, okay? From A to C to B is 300. Because all you do is subtract 360 from the small central angle. Does everybody understand that?
Can't go past that.
And it can't go past that. And this is also a way that you can distinguish between a minor arc and a major arc. Minor arcs are written with 2 letters. Major arcs are written with 3 letters. And honestly, they really will tell you like the direction in which you go, okay? So if it's 2 letters, you know it should be less than how many degrees?
180.
180. So that's why you know you're going from here to figure out that minor arc. Major has 3 points. You go from A to C to B. That's how you also know that that should be a major arc more than 180. Make sense? Cool. Couple of postulates and theorems that we'll run through real fast before we get to some examples. Arc addition postulate is the addition postulate that should sound familiar from something. Blank addition postulate, a little louder. Segment addition postulate, y'all remember that, right? Chapter 1, this segment plus this segment equals the whole segment. There was another addition postulate, angle addition postulate. The small angle plus another angle equals the big angle. So you can assume what arc addition postulate is, right? A little arc plus another little arc equals the whole arc. Same concept. Cool? That's exactly what you have here, okay? The measure of arc ABC is the measure of AB plus BC. Simple enough. So if AB was 50 degrees and BC was, I don't know, 80 degrees, what is the measure of arc ABC?
130.
130. What if I said that ABC was 150 and arc BC was 70? What would be the measure of arc AB?
80, 20. What?
It would be 80, because you would just take the big arc and minus the small arc. It works both ways. Okay? Congruent arcs clearly are 2 arcs of the same or congruent circles that have the same measure. So if 2 angles are congruent, That means their arcs are congruent. You see right here in this example where it's both 45?
I was gonna ask that earlier. I was gonna ask that earlier.
Yep, same concept applies. So that means that arc AB would be congruent to arc CD, even when they're not in the same circle. If they have the same central angle, you see these with 95 degrees, that means that arc PQ is congruent to arc RS. Or when you have one circle within another circle, what is that called? We talked about this Monday.
Concurrent, something close.
Concentric circles. When one's within another, you see how they both have the same central angle of 70 degrees? That means that arc XY is congruent to arc ZW. Wait, I'm sorry.
What?
I'm sorry.
They're similar. Right,
Yes, they're similar, but they're not congruent. Let me rephrase, sorry.
Sounds like
So when they're like that, they're always gonna be similar and not congruent?
Their measures would be, but like, say, like the actual distance themselves, like from X to Y and then from Z to W, they wouldn't be. Questions? It's a lot of just hitting on some definitions and things, okay? But once we get to examples, I don't want you to be like, oh, I don't know what a major arc is. So is everyone okay?
Yes.
What is a major arc?
It's above 180.
Greater than 180, less than
Less than
360.
Above 180, less than 360, and how do you know if it's a major arc?
It's got 3 letters.
It has 3 letters. A semicircle is half a circle, which is how many degrees? 180. A semicircle, is it named with 3 points or 2 points?
2, 3.
Well,
I didn't go over that, but I need to. It's 3. It's 3. Okay? Let's take a look at some examples that deal with arcs. Like this one. And then we'll get to the chords. Okay? So we have MQ, segment MQ and segment NR are diameters. Think about it. They're diameters. What do diameters do to a circle? Cut in half. Okay, so we need to find the indicated measure. Raise your hand if you can figure out what is the measure of arc MN. Child. And you know this because of what reason? The angles are congruent here. And if the angles are congruent, that means the arcs are congruent as well. What kind of angle is this? Well, these are vertical angles, yes. But this one particular angle is called what? Just went over it on the very front page. Not acute, not minor. Like what's alright doing, she's looking back.
Wait, what? Minor?
A central angle. Central angles are congruent to their arcs. The measure of NQR. The measure of N to Q to R. Raise your hand if you think you know what that measure of the arc is from N to Q to R. Casey.
180.
180. N to Q to R, that's half the circle. So that's 180 degrees. What about the measure of arc PN? Raise your hand if you think you can figure out the measure of arc PN.
Wait. Whoa. Wait, so the measure is the same thing as the degrees, the angle
Yep.
connected to it, but it's not like its own. That's not the actual measure, right? Or is it?
Yes, exactly the measure of the arc. Not its length, but its actual measure.
Measure.
Mhm.
Okay.
That.
Alright, that's fine.
What is it? It is 81. Very good. Okay? So PN, the central angle was 81. You see how this is going? Take about 2 minutes to try to fill out the rest, okay? Take about 2 minutes to fill out the rest. So remember, the measure of the central angle is going to be the measure of the arc, okay? So, QR, the measure of arc QR, did anybody figure it out? Christian? It's 73, because its central angle is 73. Very good. What about the measure of QMR? Teresa? Gotta be careful. We gotta go from Q to M and then to R. Let me, huh? 287. And you get that from doing what? Exactly, 360 minus 73. 360 minus 73. For the next one, PRN. P to R to N. 3. 279. P to R to N, and you get that from doing what?
By going, adding P to R and then R to P.
That's one way you can do it. Yep. P to R and then R to N. What's another way you can do it?
360 minus 81.
360 minus 81. Either way, you still get what? 279. You see how it works? Also, take a look. The ones that are labeled with 3 letters, weren't they bigger than 180?
Yes.
So then there you go. In Q, I know it has to be less than 90, or I mean less than 180.
I got 99.
In Q.
107.
107, how do you get 107?
70. That small one's 26. You just add 81.
Yeah.
The small one's 26.
I got it 27.
Well, 81 plus X and 73 have to equal 180. So that would have to be 26. What about M, R, P? M to R to P. 206. What was the measure of this central angle? 107. And you knew that because this one was 73. Okay? What about the measure of M in Q? 180. What about the measure of MR? 107. It's just the measure of the central angle. So a lot of times, if they give you a circle, they only give you a couple of central angles. Maybe finding those central angles first could be helpful, because then all you gotta do is just add or subtract where you need to. What about PQ? 26. That was the measure of the central angle. And the last one, the measure of MQN. 287? Very good. Questions on the arcs and their measures?
Just following the order, that's all, man.
Yep, order matters. And remember, if it's 3 letters, gotta be bigger than 180, less than 360. 2 letters, less than 180. Okay, we're gonna shift over to the chords now, okay?